Well, now we have understood the three most important concepts of the chapter, that is the concept of current, the concept of potential difference and the concept of resistance. Now, they are somehow interrelated with each other and their relation was obtained by a scientist called as George Simon Ohm, and that entire procedure is given by a law named as the Ohm's law. So, to understand the Ohm's law in detail, let us consider a simple circuit diagram. So, here we have a resistor, or basically we can say we have a conductor with some resistance present inside it. Across it we have connected a voltmeter. So, this V, it denotes voltmeter, and voltmeter is always used to measure the potential difference across a conductor. Similarly, this A out here, it represents another device. It is used to measure current and it is called as ammeter. Then we have a key. It is used to control the flow of current. If I open the key, the circuit will become an open circuit and no current will flow through it. Whenever there is a dot, it means the key is closed, which means the circuit is closed and current will flow through it. There is a battery having positive and negative terminal as well. That means as soon as we close the key, the current will start to flow through the circuit, which I have represented by the letter I. The ammeter will measure the amount of current and the voltmeter will measure the amount of potential difference. Now let's say that initially the battery consisted of only one cell. So when there was only one cell, let's say the reading of the ammeter was 2 ampere and the reading of voltmeter was the potential difference of this cell, that is 5 volt. Now if I connect one more battery out here, obviously if the strength of this cell is same, that means the voltage will now double up, it will become 10 volt, and at the same time if I check the reading of ammeter, then it is found to be 4 ampere. If I go on to increase one more cell having the same strength, the battery voltage will again increase to 15 volt, whereas the ammeter reading will now change to 6 ampere, and so on. For 20 volt it will be 8 ampere. Now, is there any observation that you can very easily make out from this? Well, I think I have given you the obvious hint, V upon I. If you divide all these things, let's say 5 divided by 2, answer is 5 upon 2. When I go for 10 upon 4, 10 upon 4 is nothing but 5 upon 2 again. If I go for 15 upon 6, even that gives me 5 upon 2. And if I give 20 upon 8, the answer for that is 5 upon 2 as well. So from this we can very easily conclude that V upon I is coming out to be a constant. In this case, the constant is 5 upon 2. Whenever the division of two quantities is constant, it means they are directly proportional to each other. That means electric current is directly proportional to potential difference. And this is what we call as the Ohm's law. Now, we will first have to formulate the definition of Ohm's law. The definition is as follows. The electric current flowing through a metallic conductor is directly proportional to the potential difference applied across its ends. So, that was what was given by Ohm initially. However, as experiments went on, Ohm realized that there are certain factors which affect the resistance of a conductor. We will be studying these factors in detail in the videos to come, but as of now, the factors are length, area of cross section, material, and temperature. If any of these things is changed, then the relation between I and V does not remain to be constant. That means the ratio will not be constant anymore. And so to ensure proper statement for Ohm's law, we modify it a bit. So the statement for Ohm's law will now become the electric current flowing through a metallic conductor is directly proportional to the potential difference applied across its end, provided physical conditions of the conductor such as its length, its area of cross section, its material and its temperature remain constant. If all these factors are unchanged, then definitely the ratio of V upon I will be constant. Now, there is only one thing which can remain constant in a conductor, and that is its own resistance. Remember students, when we talk about these three key concepts of current, potential difference and resistance, wherever there is electricity, all these three concepts would be there together. Even for a similar or a simple example like an electric bulb or an electric fan, even in those small devices, you will have all the three concepts working together. That electric bulb has some resistance inside it. So to ensure the flow of charge or to ensure the flow of current, potential difference is applied. So that means all the devices, whether we are using them or not, they all have some amount of resistance inside them. What we provide them by connecting them with the switch or the circuit is potential difference. Any device which has resistance and is connected to a source of potential difference can withdraw current on its own. And so each device will then start taking current as per its requirement. So even here, if the resistance changes, everything will not remain constant. So that means the only factor which remains constant in a metallic conductor is the resistance, and so we can say that V upon I is actually equal to the resistance R, which helps us to obtain the final formula for Ohm's law, that is V equal to I into R. This is the most important formula in this entire chapter, and this is what we call as the Ohm's law. Now that we have understood what is Ohm's law, let us also try to understand the graphical representation of it. So here, as you see, we are going to draw a graph of potential difference versus current. This graph is also known as the VI graph. So in the VI graph, on the y-axis, we have plotted the values of potential difference, and on the x-axis, we have plotted the values of current. So let us go with the same values which we have taken out here. So if I plot the same values, obviously because V upon I is a constant, the line which I will be obtaining would be a straight line passing from the origin. This line out here, if you try to find its slope, then we know the formula for slope of any graph is always y upon x. Here on y-axis we have voltage and on x-axis we have current. I hope you remember what is V upon I. It is nothing but R. That means the slope of VI graph actually gives us the resistance of the conductor. So more the slope, more will be the resistance. To understand this in a better way, let me draw another graph out here. Let's say this one. Let's say this is denoted by R1 and this is denoted by R2. Now just try to figure out which one of them has more slope. Well, to identify that, just imagine yourself at this point and trying to look down. So when you are from point R1, you see that the slope of R1 is more as compared to R2. As you start approaching the x-axis, the slope will start reducing, and as you start approaching the y-axis, the slope will start increasing. So the slope of R1 is more than the slope of R2, and if the slope is more, the resistance will also be more. That means we can say that R1 is greater than R2. So this is a graph between V and I, called as the VI graph, that is obtained using Ohm's law, and it is of immense importance from our examination point of view.